Everything we've done up to this point was to solve right triangles. What happens if you do not have a right triangle? Okay, we can't just use Pythagorean theorem. That's out the door if you don't have a right triangle. Now you could try to make a triangle into a right triangle and use that, but that doesn't always work out. So we have some other laws outside the Pythagorean theorem and the sine, cosine, and tangent. We have law of sines. Law of sines is sine of A over A equals sine of B over B equals sine of C over C. Notice that the angles are all capitalized and the sides are all small, and that applies to the triangle. Any triangle, A, B, C, little a is across from big A, little b is across from big B, and little c is across from big C. Now, this doesn't solve every single situation that you're given. Okay? This solves specific situations, like when you guys prove triangles congruent. You remember angle, angle, side, angle, things like that? Okay, we're not proving triangles congruent, but we're going to use that to identify what type of triangle we have or what's given, so we know what to use. Okay, what works for law of sines is angle, angle, side, and angle, side, angle. Those two types. If that's what's given, you can use the law of sines. Okay, angle, angle, side, angle, side, angle. So let's take a look at an example. Solve triangle ABC. A equals 33 degrees. B equals 105 degrees. And B equals 37.9. I'm drawing the same triangle every single time. It would be nice to try to make it look like what it's supposed to. Obviously, A is a smaller angle, so if we had A at, say, 105 instead of B, we would probably want to switch it up so it looks like it's going to work. B looks like it's bigger, 105, and side B, 37.9. We don't know side C, we don't know side A, we don't know angle C. What triangle do we have here? What's given? Right. We have an angle, and a side. And the order matters. Okay? If the side was here, it would be angle, side, angle if we had C instead. But it's angle, angle, side, which is one of the ones we can use law of sines on. So, sine of A over A equals sine of B over B equals sine of C over C. Plug in everything that you know. Now, can I plug in what C is? In other words, can we find C? What's C?
20 minus 25 minus 33
which is how much? 42 degrees. So we can find C. So sine of 42 over C. So we need to find side A and side C. Now here's how it works. I know it looks a little complicated, but we're going to make it easy. What do you want to solve for, A or C? Pick one. A. Whatever you're not solving for, cover up. So we have sine of 33 over A equals sine (105) divided by 37 point. It's supposed to be a 9. Whatever you're not solving for, cover up. We don't want it. So you're basically eliminating one of the fractions. We have a fraction equals a fraction. Cross multiply and solve. So 37.9 sine of 33 degrees equals A sine of 105 degrees. Dividing, you get 37.9 times the sine of 33 degrees all over the sine of 105 degrees equals A. So let's put that into our calculator. 37.9 sine 33 divided by, sine of 105. Looks like 21 point. Well, let's see, what do we want to round to? Let's just go to the nearest tenth. So 21.4. Okay? And then we do it again. We go back up. In this case, we'll cover up sine of 33 over A, or take that away, which leaves us with the sine of 105 over 37.9 equals the sine of 42 degrees over C. We solve for C. Really, it's the same process of solving. And again, we can type that into our calculator and get a solution. .3. So, yes, question. Well, we cross multiply. So, fraction equals fraction. This goes to the top. This goes to the top. Just cross multiply. Do that. It's going to show up a lot with these problems. All right. That's about it for today. Running out of time, so we'll finish up with the rest of this tomorrow.